All right, let's get into it. So, one of the first things I like to do is when I use the Cintojon MEP design toolkit to do my design, I like it to be, designs that are projects that are quite, massive. You understand? Like estates, high-rise buildings, projects that require a lot. Okay, but of course, this is just a sample building. You understand? So I'm not teaching you how to do MEP designs here. You're professionals. We're just looking at how we can, make the work faster, more efficient, and with fewer errors. Okay, using the toolkit to assist us as we go. And one of the advantages of the toolkit is that if you just know how to use your AutoCAD commands, okay, the toolkit can guide you into designing a full electrical, plumbing, HVAC system. That's the beauty of it. All right, so you're sure of what you're doing and you're fast at what you're doing. Okay, especially when you're doing a very massive project. All right, that being said, so let's use this as a sample building. So I'm going to start with this right now. So this is a room, but first let me get into my Cintojon MEP design toolkit. So just log on to cintojon.com. All right, just go and log on to cintojon.com, or you just search for cintojon.com and click enter. Okay, so that's it. So I'm just going to log in right now. All right, that's me there. I'm just going to sign in. All right, so I'm going to the toolkits session. These are the training sessions, by the way. If you're interested in any of our trainings, okay, you can come to the training sessions. All right, so you just go to the available courses over here. You'll see the courses. You see some free courses there too, and some like this you have to enroll for all these ones. Like AutoCAD, that's what I was talking about the other time. When you just take this AutoCAD fundamentals for MEP design alone, and you understand how to do the basic commands, you can just use the toolkit to design your mechanical, electrical, and all that. So, all right. So, that being said, we'll go to the toolkit session, and you can see this. So let's focus on electrical first. Let me go back again so you understand what I did. This is the electrical design toolkit. We want to start with electrical right now. All right. So it defaults to the settings page. You can see the electrical design toolkit, professional electrical load calculations, and design tool. So the first thing is that you want to have your settings in place. Now, this is very flexible. Whether you have your settings or not, you know how the codes you use, how you label your circuits and all. That's up to you. You understand? So I'm just going to do it the way I do it. You know how to interpret it the way you do yours. Okay? So the first thing I'm going to do is that my lighting, I like to label my lighting like L1A, L1B. That's my circuits. All right. So my sockets, I like the P. Then the dedicated, sometimes I like P or H. So let me just use H here. Then, but the first thing I want to do now is that I think I want to clear out the data because I have data. If you come here now, I have some distribution boards here already. So I want to delete the data. But the beauty of it is that before I delete this data, I can export the data. So if you're working on it, you can come here and export data. Okay. So I'm just going to export the data of what I have there already. So, so data exported successfully. So I'm going to just save it somewhere now. All right. So I'm just going to save this one in my students folder. So when our students they send me their work, I check them, I and my team. Okay, so data is exported successfully. Okay, so it's beautiful. So if I want that data, if I want to use that data back for this project, I can just simply go to import data. So I'm gonna go to say students. This was the data I exported earlier. I'm just gonna click it, open, and it imports the data perfectly the way it was on the whole thing the way it was before. So now that I've exported the data, I hope you understand that when you export data, the data as it is, all the distribution boards that you have filled. If you go to the load schedule currently now, go to the load schedule, you can see the load schedule, you have the load schedule there. All right, done because of the project I had done previously. If you look at the panel for different load schedules, I have this final panel. Okay, these are the total load, demand, current, cable size, everything is there. So the individual distribution boards and all that. So I've already exported it. Now what happens that if I import it again in the back into this toolkit, if I import into this toolkit, what will happen is that all my lighting, see if you can see my lighting, it will all have been done. My sockets would all have been done. Air conditioning, all have been done. Dedicate just as it is, okay, it should have all been done. So I don't have to start it again. So that's the beauty of it. You're working, you're not done, or you have to do something else. You just export your data and put it in. We want to continue, you log into your dashboard, you import your data and continue for where you stop. Beautiful. All right, so now that I've exported, I'm going to click on this factory reset to clear everything here in this DB, in this toolkit. So you see, this will permanently delete all your data. Are you sure you want to continue? Yes. Click OK. Yeah, so I'm free now. There's, you see, select DB. There's just defaulted to one DB there, DBA. So now let me create my settings again. I have L here, I have P, I have H. The circuit suffix is active DB. I like to label my DB A, B, C, D. If you depends on what you want to label your DB. So if you come to this distribution boards, where is that distribution board? DB. For active DB, I can say DB. Sorry about that. I can say DB, the suffix. If I call my DB 1 2 or 1 2 1 3, whatever it is, that will be the suffix. So if I say DB 1A, okay, and I add DB, all right, okay. So now I have DBA, I have DB1A there. Do you understand what I'm saying now? So I can add DB, but I'm just going to delete this one right now. So if I want to delete DB, I just select the DB to delete. I can delete this DB. I can even, let me see. So you can select any DB to delete, but you must leave one distribution board down. So if I want to delete DBA, I'm going to click on, okay, sorry, this is where I delete DB. You can see delete DB. If I want to delete DBA, I click on DBA and I delete DB. If I click delete, it will say, are you sure you want to delete DBA? This will apparently remove all lightings, but of course I've not put anything on it yet, okay? I'm going to click cancel. So the one I created was DB1A. I'm going to delete it. All right, so the only active DB here is A. I'm just trying to show you that the suffix here, okay, is what is here. So it depends on how you name or number your DB. But this is how I like to name my consumer distribution boards or consumer units, whichever one you use. So, all right. So what else are we looking at here? Lighting start number. How you start your lighting circuit. I like to start my own with L1 dash the DB suffix A. That's how I like to do mine. For the sockets, I use P1 dash A. Okay. For the heated units like the water heater, the cooker units, I use H. Very simple. And I also start with 1 for lighting. The power to the socket, I start with 1. And for the heaters and the cooker units, I start with 1. So that's about it. And it is explained here. Starting number for lighting circuits label, starting number for socket circuits P1, P2, and all. Starting phase for all circuits. Okay, you can set it here if you want. Red, because let's just continue right now. So you can start. I like to start with the red phase. Whatever phase you start with, it doesn't really matter. Now, allowable watts per circuit for my lighting. I like 1,500 watts. You set it here. So like I say, it's flexible. Whatever it is you do currently, you're not changing anything. It's just going to work aligned with what you do currently. Now we're just talking about the settings here. So maximum points per circuit, I just leave this one because as long as it's more than 1,500 watts, the toolkit is going to split over to the next circuit intelligently because you already told it how you label your circuit. So if you label 1A, if you have more than 1,500 watts on one circuit, you just split over to L2A automatically for you. So that's that for that. Now the breaker I use for my lighting is 10 amps. Now the default efficacy lumen per watt is also flexible. You can change this 120 here, but in a lot of the lighting you have, they average around 80 85. Like if I go to these sites now, this is a Google site, and I look at 12 watts now. If you look at this 12 watts, it's saying 1,000 lumens. To say this 12 watt LED downlight has 1,000 lumens. If you divide 1,000 by 12 watts, 1,000 by 12, you have 83. That's 83.33. That's about 83.33. If you look for another one, this one has 1,020 lumen per watt. Let's look at it. 1020, and it's also 12 watts. Can you see it's 12 watt LED download divided by 12 is about so 85. Okay, so we have 85, we have 83. So what I like to do is you can leave it at this, okay, or you can change this to say 85 per watt based on, it's because this depends on the manufacturer rather. So it's based on manufacturer details. So that's how you get this one. I just showed you that now. So in fact, I should have been charging for this also. So socket settings, I like to use 10. Whatever it is you use, you just put it. That's max per circuit for our ring sockets. Then I like to use 300 watts per point. Some use 250. So use this depends on how you want it. Okay. For my socket breakers, I like to use 30 amps. Beautiful. So when you're changing, it's saving automatically. It's very intelligent. Now dedicated for AC, water heater, cooker. AC minimum watts per unit. I use 2000 watts and I use my 20 amp breaker. That's for the wall hung units. All right. The smaller units. Okay. For the water heater, I use 2000 watts and I use 20 amps. For cooker units, I just stick to 3000 amps and 30. Now, this, whatever it is you use, you just change it to it. Some people use 4500 watts here and they use for, I don't, depends on what you use, okay? But I just stick to 3000 because these days a lot of people use induction. So I just stick to these. Then my supply voltage is 230. You can change it to whatever it is you use. 400, some use 415. Your power factor, I like to use zero point 0.8. You can use 0.9, especially if you are dealing with. So some people like to have all their air conditioning on one distribution board. If you're doing a design like that, you want your power factor to be almost like maybe 0.9 or even 1. Okay, so that's if you're using AC, if you have a dedicated distribution board for air conditioning. Okay, so that's that about that. All right, so okay, so I think we've gone through all this now. I have the first DB I'm using is DBA, and it's going to be my active DB. Say set active DB. Okay. Now, is my DBA, is it going to be single phase or three phase? I'm using three phase. If you're using a consumer unit, you put it there single phase. All right. Put a single phase consumer unit there. Then what then? So if you're using a single phase, you have to choose which phase you're going to be using. If it's going to be red phase, it's going to be yellow phase, it's going to be blue phase. You select it there. Okay. All right. So if you use these tools, if you migrated an old project and some items have no DB tag yet, so maybe you migrated an old project, you understand, and you have not tagged some items to distribution board, you can just tag all unassigned items to DBA, the current DB actually. So what that does, because the toolkit is very intelligent, it knows your lighting because you're already set, it knows your power, it knows you're dedicated, so it will just intelligently, the way you have set it, you just intelligent assign all those things to it. Simple. Very, very intelligent. Okay. So, but right now I'm using three phase. So that's that. And we are good. Now let's start our design proper.